you doing? I'm your man, John Wilson. We got a good one for you today. We're going to do Module 4, Lesson 2, and specifically, we will understand how to determine the slope and the y-intercept given a graph, table, and equation. Super easy. Gets a little bit more difficult, still visual. Finally, we bring the math into it on the table side. We will then apply this to real-world problems and situations, because all the math we do in here relates to the real world. We don't do anything that exists in the world of fantasy. We don't talk about dragons or unicorns, except for the one that I bought when I won the lotto. All right, so this linear equation right here, this is a linear equation, and it is in the slope-intercept form of an equation. This equation right here is one of the most important things you can take away from Module 4 because we build on it. It grows as we cross through into Module 5 and 6 and 7. As you guys know, when I'm teaching Module 4, you're also learning parts of 5 and 6, so please make sure you remember this equation right here. And it's written y is equal to mx plus b. What you need to know is that the b can be plus or minus, but when we write out this form of the equation, we just use the plus symbol. Okay, anyone have an idea, Fiamma, since you're anyone, do you have an idea what m represents? We've been using it. We used m. Dylan knows. Anybody who knows what m stands for? Okay. Now let's go. What does m stand for? Slope. M is the slope. So when we write an equation in this form, m is the slope. That makes sense because we're talking about the slope-intercept form of an equation. If that's the slope, then slam Tana. What does the letter B represent?
I don't remember.
Okay, well, let's just think about it. This is the slope-intercept flow. Slope-intercept. M is the
Slope.
which means that this should represent some type of
Intercept.
Anybody have an idea? We talked about it last time. Connor? It's the y-intercept. So B is your y-intercept. Y equals mx plus. Y equals the slope next to the x variable plus or minus the intercept. Now the graph of this equation is aligned with a slope m and a y-intercept b. Just reiterating, make sure that you know that m is the slope, b is the y-intercept. So the y-intercept, 3 different ways we can identify the y-intercept. From an equation, the b value is the b value in the slope-intercept equation, and y equals mx plus. That is your y-intercept when we're talking about an equation. When we have an equation in this form, the b value is always going to be your y-intercept. That's the equation. Simple. Easy to spot. Can all of you spot this? Yes. Easy to spot. When we have a graph, the y-intercept is where the line crosses the y, also known as the vertical axis. Wherever the line of the graph crosses the vertical axis, that is your y-intercept. We're going to go into each one of these in detail. Right now, I'm just letting you identify the 3 different ways where we can determine the y-intercept. On a table, it's where the x value is equal to 0. That's the y-intercept, wherever x is equal to 0. Let's deal with the equation first. Let's deal with the easy stuff, because that's fun. Matthew, I'll give you a tick in a second. Same thing for, I already gave you one. Madison, looking at this equation. What's my slope? What's my y-intercept?
4.
4 is my?
Oh, no, 5.
5 is my what? Slope of the y-intercept.
The y-intercept.
Okay, so y-intercept is 5. That's fine. That's part of it. What's my slope?
4.
4. Good. 4 is the slope. 5 is the y-intercept. Jennifer Gutierrez, where you at? Moved you over there. Top right. What is the slope? What is the y-intercept?
Slope is 8, and the y-intercept is -6.
Good. Slope is 8. Keep in mind the y-intercept here, that negative, is part of the term. It's -6. Any questions on the second one? Maldonado, you good on these 2?
Yeah.
Yeah, okay, Maldonado, help me with this one. What's the slope? What's the y-intercept?
The slope is -12, and the y-intercept is 25.
You got the slope right, and the y-intercept is -45. Keep in mind, these are terms. That's my y term. This is my x variable term. That is the constant. And that negative sign is part of it. That's your y-intercept. Don't ever forget to write the negative. There's a big difference between 45 and -45, right? Yes? We sure?
Yes.
Think about it. What would you rather have in your bank account? $45 or -$45? $45, because there's a big difference there. I, on the other hand, have like -$45 million. No one wants that. Okay, I'll give you a ticket in a second. And Jennifer, I'll give you one. Lucas, last one there. What And by the way, yes, your slope and your y-intercept can be fractional. So Lucas, what is your slope? What is your y-intercept?
My slope is 5/6.
All right.
My y-intercept is positive 7/9.
Positive 7/9. If it's positive, do I need to write the plus sign? No, I don't. But if it's negative, do I need to write the subtraction with a negative symbol? Yes, I absolutely do. Any questions on these?
No.
Then I do want to point something out before we move forward. You don't need to write this down. I just want to ask you guys a realistic question. Think rationally before you answer this. Christopher, looking at this, what's my slope? Okay, but we need a number, right? Because in all these examples, we had numerical values for slope. So looking here, let's think outside the box. You don't see a number here, right? But ask yourself a question. How many x's do you have?
1.
So what's the slope?
1.
1. What you don't realize is there is an invisible number here. What's the invisible number?
1.
1. There's an invisible 1 right there, which means my slope, if I don't have a number, if I just have an x, my slope is 1. But what if I have a negative x? What would my slope be?
-1.
Negative 1. So this is negative 1. Christopher, I'll give you a tick in a second. Ali, give me the y-intercepts for both.
6 and positive 6 and positive.
Positive 6 and positive 3. Any questions on any of this? All right, let's prove it. 4, 3. Now, we're going to find slope and y-intercept from a graph. Ugh. All right, so the graph, by the way, the graph of every non-vertical, what does vertical mean? What does vertical mean? You're making the, what is this, the FSU's? Oh! Yes, it means up and down. Up and down. Vertical is an up and down line. Horizontal is, in case you ever forget, imagine you out at the beach. You sitting there chilling. You got your Pepsi Cola. You got your water. You got your lemonade. Okay? You're sitting out. You're looking out at the water. What do you see far off in the distance? The horizon. And the horizon runs left to right. Okay? In case you ever forget what vertical is. All right. The y-intercept is the y coordinate of the point where the graph crosses the y-axis. So we care not at all about the x-axis. We don't. All we care about is the y-axis. I'll let you write that in, and I want all your eyes up here. Explain this real good one time. It should make a lot of sense to you. So we have two axes right here. We have a y, we have an x. We do not care about the x. What we care about is looking at this line right here and trying to identify exactly where this line crosses the y-axis. Does everybody see where this green line crosses the y-axis, yes or no?
Yes.
Yes, and we can draw a little point there. It's right there. The line crosses the y-axis right here. That is your y-intercept, where this line crosses the y-axis. We can label that using a coordinate pair. What, Connor, would that coordinate pair be, where this line crosses the y-axis?
It'd be 0, 5.
It'd be 0, 5. Good job. I'll come give you a tick in a second. Let me explain to you exactly why it's 0, 5. First of all, whenever you have a y-intercept, you already know half of the coordinate pair. Half of the coordinate pair is always going to be 0. Whenever you have a y-intercept, the x value must be 0, because it must be on the y-axis. Any point on the y-axis, the x value is equal to 0. The x value will always be 0. Now, how did he get the 5? Just to make sure you understand exactly how he got the 5. He started at the origin. You with me? To get to this point, did he have to go up or down? Up. And when we start at the origin, if we go up, is that positive values or negative values?
Positive.
Positive. Now this graph is going up by 1. 1, 2, 3, 4. 1, 2, 3, 4, and 5. Which means at this point is 0 on the x-axis and 5 on the y-axis. The coordinate pair is 0, 5. It's very simple to identify these. Just don't ever confuse y-intercepts with x-intercepts, which is where the line crosses the x-axis. All we care about is where this line crosses over the y-axis. All right. Yeah, we got time. We'll do one. Then we'll go to lunch. We'll do one, then we'll go to lunch. All right. So we're being asked to identify the slope and the y-intercept. The y-intercept here is visual, right?
Mm-hmm.
So we can identify the y-intercept simply. Not sure why a lot of us are going to our book bags. Lunch is in 6 minutes. Just wait, I will let you go. All right, so looking at this line right here, is this the y-intercept?
No.
No. Is this the y-intercept?
No.
Is this the y-intercept?
No.
It's not even on the line. The y-intercept is
Yes.
Yes.
right there. Okay. We'll come back to find the slope for that in a second. Where's the y-intercept here? Is it here?
No.
It's up here, right?
No.
It's right there?
No.
It's down here.
No.
Is it there?
Yes.
Yes. Okay, so then let's just figure out what. Connor, I owe you a ticket, right?
Yeah.
Maldonado, what's the y-intercept of the graph on the left? So Maldonado, 0,6 is a good coordinate pair to use because we're trying to find our slope. So 0,6. That's our first coordinate pair. Good. Now we need, let's go to this one. What's the y-intercept going to be here, Francesca?
0,
0,1. And that works for us as well because we can use this coordinate pair to help us find the slope, which is the second part of this question. Lucas, I need another set of points here in order to find the slope. Give me another coordinate pair. Give me another lattice point. What do you got? There's a whole bunch of lattice points I see here. Can you give me a point?
Last point.
Give me a lattice point where this line goes through the grid lines. Give me something. It's okay, he's got it.
-1 to +3.
-1, +3. Good, we can use that. We could also have used this one, right? -2, 0. We could use any 2 points on this line. Will we always get the same slope?
Yes.
Yes, we will, because this is a linear relationship. It's a constant rate of change. We will get the same slope. Doesn't matter if I use these 2 points. Doesn't matter if I use this one, or this one, or this one. No matter which 2 sets of coordinate pairs I use, as long as I do my math correctly, I will get the exact same slope. So we're going to write, and this is -1, 3. So I have 2 sets of coordinate pairs. Let's go to Shimon. Shimon, I want to find the slope here. So let's start off by identifying our 2 y values. What are my 2 y values here?
6 and 3.
6 and 3. So these are my y values right here and right here. Which one's going to be your y2?
6.
6, because it is the
Height.
it's the larger of the y values. Notice, it's not the larger. We don't care if it's the larger of all 4 values. It happens to be. All we care about is it's the larger of the 2 y values. So this is the larger one. This is y2. This has to be
X.
x2. If this is y2, this has to be x2 because coordinate pairs are written x, comma, y. This is y2, this has to be x2 because it is the x value that corresponds to this y value. So if this is y2, this has to be y1. If this is y1, this has to be x1. Now we can substitute this into our formula. Alicia, tell me. What am I going to write? 6 minus 3, y2 minus y1 over 0, immediately, right? The subtraction sign, 0 minus 1. What is 6 minus 3? 3. These 2 negatives form a positive. Remember, it's when they're right next to each other that happens. And this will become 0 plus 1 is equal to 3 over 1. And what's 3 divided by 1? 3. You will not leave it as a fraction if it simplifies to a whole number. This becomes 3, so my slope is 3. What was my y-intercept? 6. So, to finish all this off, the cart left. Write my equation. What's my equation going to be? In y, in this format, what's the equation of this line? 3, okay. Beautiful. The equation of this line is y equals 3x plus 6. Good job. Any questions on that first one? All right, so now that we got that first one out of the way, let's take care of this second one. So we already found the y-intercept. The y-intercept was 0, 1. We need 1 additional point to do this. So let's go to Flash. Savior of the universe. Flash.
What? He's the savior of the universe.
Flash.
You guys ever see that?
Flash. I need another coordinate pair in order to find the slope. So, give me one. What do you got? Remember, we're looking for lattice points.
The x is -4.
Okay. And the y would be 4. Just the person I'm working with, please. Yeah, good. -4, comma 4. That's the lattice point. Good. Set on the line. We can use it, so we'll do -4, comma 4. Now let's go. We want to find the slope here. So, what are your y values?
Y2 is 4.
Okay, y2 is 4 because that's my larger of the two y values. So that's my y2. What's this going to be then? x2. Who's ever saying y1? No, it's not. And y1 is going to be 1. And what's this going to be? x1. Good. Now that we have that, let's substitute into our slope formula. So what am I going to write, Velasco?
4 minus 1 over -4 minus 0.
4 minus 1 over -4 minus 0. And Herrera Sean.
Okay.
What, when I do the subtraction, what am I going to have there? What's 4 minus 1?
3.
Okay, good. And what is -4 minus 0?
-4.
-4. And a positive and a negative make a negative.
Wait, what?
Positive and a negative make a negative. So this is -3/4 in case you were curious. So that's my slope, -3/4. Let me fix this 3 because it kind of looks like a weird looking 9 there. So we're going to have -3/4. -3 over 4. And then what was my y-intercept, Rudy?
1.
1. My y-intercept is 0, 1, so I'll just write 1 here because I'm trying to write the equation. I want to write my equation. Nieto!
Yeah.
What's my equation going to be, bro?
Y equals -3/4. And then x plus 1.
Y equals -3/4 x plus 1. Good job. Good job. Any questions? Questions on this? Questions on this? No? We good? Very good? We're sure? All right. 4, 3, 2, 1, 4. So, what we have here is finding the y-intercept from a table. Depending on the table, this could be easy, this could be hard. When we're given a table, the y-intercept, which is also known as, this is key, you must know that the y-intercept is also known as the initial value. This is probably the most important vocab word in the module, initial value. Y-intercept, initial value, exact same thing. Initial value is the coordinate pair where x is equal to, put a little box around that, x is equal to 0. So if you're given a table of values, and you look at the values, and you look at x, if you find 0, do we see 0 up here on the x values?
Yes.
If you find 0, that means that they were kind enough when they created this problem to give you the initial value, aka the y-intercept. So what's my y-intercept going to be here?
0.
0, comma
3.
3. My y-intercept is the y value where x is equal to 0. Do you think we're always going to be given 0 in a table?
No.
No, absolutely not. It'd be nice in a perfect world, but unfortunately we're not always given the y-intercept. If we don't have the y-intercept, it's a 2-step process when given a table to go and numerically find the y-intercept. The first step, something you already know how to do. Do we know how to find slope from a table?
Yes.
Yes, we've done it before. So the first step is to find slope from a table. Just remember, if there is no constant rate of change, that the relationship is not linear, you can stop right there. Sometimes you'll run into that. If you find the constant rate of change, also known as the slope, then you move on to step 2. You will then substitute the slope, and don't worry, I'm going to walk you through how we do this, and the pair of xy coordinates into the slope-intercept equation, and solve for b. Looks like, wait, hold on, man. This looks like it could be complicated, man. We got to do some math, some multiplication, addition. How many of you, once again, can solve one-step equations? How many of you can solve one-step equations? Most of you? How many of you could solve something, let's just say, how many of you could solve something like this? 50 is equal to 20 plus b. How many of you could solve this? I would expect most of you to say you could solve this. This is all you're going to really be doing. If you can solve this, you can find the y-intercept, because the y-intercept is what? What's the y-intercept?
30.
B. And we would subtract 20 from both sides. You can solve a one-step equation. My b, or my y-intercept, would be 30. Let me walk you through the process. All right. So, we want to find the initial value. Notice that I say initial value. Initial value is the exact same thing as the
Y-intercept.
y-intercept. So we want to find the initial value, also known as the y-intercept, from this table. Step 1. Find the constant rate of change, which is the slope. We know how to do this. We've done it before. Let's go to my homie, Dylon. We want to find the slope. So, what's the input, what's the output?
The input is the room cleaned.
Okay, and the output is?
Cost.
Cost. Perfect. So we need to use 2 sets of coordinate pairs. Smaller ones are better. What do you want to use?
Like any random.
Coordinate pair, coordinate pair, coordinate pair, coordinate pair. You can use any 2 of those to find the slope. What do you want to use?
125.
1 comma 125. Okay, because we're finding the slope. And what's another one you want to use?
The 2 comma 175.
Okay, so we're using this one and this one. Doesn't matter which 2 you use, as long as x and y value, they must be corresponding. They must be on top of each other, or they must be next to each other. This corresponds to this, corresponds. Nothing different from what we've already done. 2 comma 175. We know how to find the slope here. Let's go through the routine. Dylan, what are my y values?
Your y2 is 175.
Okay, y2 is 175 because it's the larger of the y values. This means this has to be
x2
x2. Good. Means this has to be
by 1.
good. Means this has to be
x1.
x1. We substituted the formula. Have we done anything new yet?
No.
Learned anything new? No. This is all same stuff we've done before. How to find the y-intercept if they don't give it to you. So we substitute in. What am I going to write, Dylan?
175 minus 125.
175 minus 125 over
2 minus 1.
2 minus 1. That's going to equal 50 over 1, which means the slope of this table is 50. Slope, also known as the constant rate of change, is 50. So we have the first part. Now, for the new stuff. Let me explain what we're doing here. This is the slope-intercept equation. What are we being asked to find again? Initial value. What's the initial value here? What letter?
B.
B. So we're being asked to find the y-intercept. Do we know the slope now?
Yeah.
Yes. Do we know a value for y and x from this table?
Yeah.
Yes, we do. Isn't this an x value?
Yeah.
Isn't this a y value?
Yeah.
So all you do is you pick any coordinate pair from the table, like 1 comma 125 or 2 comma 175, substitute that in with the slope and solve. Let me show you how it works. I am going to use the smallest one because it makes my job easier. So this is my equation. Y equals mx plus b. Let's substitute in what we know. If I'm going to use this coordinate pair, you with me?
Yes.
Yeah.
What am I substituting in here for y? What's my y value in that coordinate pair? 125. Equals, what's my slope?
50.
50. Times, what's my x value in that coordinate pair? 1. 50 times 1 is equal, 50 times 1 plus b. What's 50 times 1? 50. Once again, this becomes very simple. 125 is equal to 50 plus b. Remember I asked if you guys can solve one-step equation? Can you guys solve this?
Yeah.
Okay. So we subtract 50 from both sides, and guess what you just found? Your y-intercept is 75. So I know my slope is 50. I know my y-intercept is 75. Can I write an equation from this? Yes or no?
Yes.
Yes, I can. What's my equation, Sydney?
Y equals
Uh-huh.
75.
Remember, slope is 50.
Oh, 50.
Y equals 50 what?
X plus
X
70.
plus 75. And then you had a question, Sydney. What's your question?
Will you always be finding B, or will you ever be finding like anything else?
You'll always be finding B. You'll always be using this to find B. Now, here's the thing. If I give you 3 of these values, can't you always solve for the other one? Like if I were to give you the y, the x, and the b, couldn't you go back and find m?
Yeah.
If I were to give you the y, the m, and the x, like I did, you could find b. If I were to give you the y, the m, and the b, couldn't you find x? Yes, if you know 3 out of 4 things, you can solve an equation to find the other item, okay? Yes?
Okay, I get like how we find to do the one-step equation, but I don't get how we do the equation.
How we substitute in?
Yeah.
Okay, so you have the same question?
No.
What's your question?
it's like, this is like all we need to do to get the answer for B.
Yeah, that's all you have to do to find the b. If the table does not give you, now look, if you look at the table, do we have anywhere x is equal to 0? No, which means, do we know the y-intercept looking at this table? No, so we had to go find it. This is the process. Let me show you another example, then we'll come back to this one. Okay, so let's say that we had our table, right? And we found our slope. Somebody give me a number, I don't care.
30.
3, 10, 5, 30. 10,
350.
10, whatever. M is 10. Let's say that in this table of values, we have x, y, and let's say that we have 3 over 15. We don't need to worry about the other tables, the other values in the table. All I need is one coordinate pair in order to find the y-intercept. So what's my coordinate pair going to be? 3, comma 15. Okay. 3 is what? The x or the y?
X.
X. And 15 is the y. So if we look at this equation here, y equals mx plus b, do I know the m?
Yes.
Yes. Do I know the x?
Yes.
Yes. Do I know the y? Yes. And all I do is substitute in. So let's go from left to right. What am I plugging in for y, guys? 15 equals, what am I plugging in for m? 10. And here's what I want to point out. What operation is happening between the m and the x? Multiplication. So we'll put parentheses here. And do I know the x?
Yes.
Yes. What's the x?
3.
3 plus b. You with me?
Yeah.
We perform a multiplication. 15. 10 times 3 is? 30. 15 is equal to 30 plus b. Looks like my y-intercept is here is going to be what? Positive or negative?
Negative.
Negative. Because I have to subtract 30 from both sides in order to get b alone. And I will end up with 15 minus 30 is negative 15, which means my y-intercept is negative 15. I can go back and write an equation from this now. Anybody want to give me my equation? What would it be? What would it be? Ali, what would it be?
Y equals 30.
What's the slope? What's the m?
10
10
x
x.
plus
You don't need the plus. What's our y-intercept?
negative 15.
Y equals 10x minus 15. Okay. What's your question?
How'd you get 10?
I made it up.
Oh.
I just made it up. I made up a random slope. If I wanted to, let's say I want to guarantee that my slope here was 10, we could say that this is 25 and this is 4, right? Okay.
Oh, and it can be like any coordinate pair or
You can use any coordinate pair. Just remember, when you're doing this, if you're going to use 1, you have to use what for the y? 125. You cannot use like 2 and 275. Are those coordinate pairs? No. This is an x value, it corresponds to this y value. This x corresponds to this y, this x corresponds to this y value. You guys with me? Do you understand how to do this? We all know how to solve one-step equations. You want to do the next example?
Yes.
Sure. Okay, let's try the next example. And then if you don't get it, I will stop and we'll do another example because this is probably the most important thing you can pull out of all of 4.2. Because I think that this right here was pretty easy. We knew how to find the slope. This is visual. That's visual. This was probably the easiest part. I mean, it gives you slope and y-intercept, right? So this, what we're doing now, a little more difficult, but it's the most important thing. We'll go right here. The good thing is, most of the stuff you're going to do for homework, most of the stuff you'll see, they'll give you the y-intercept. This is for those circumstances where you are not given the initial value. I'm going to go to Sebastian Chavez. Sebastian, hi. All right, step 1, Sebastian. We want to find the CROC, constant rate of change, also known as the slope. So, this time x and y are already given to you. I need to use coordinate pairs. What coordinate pairs do you want to use?
15 and 80.
15 and 80, okay, that's one. 15, comma 80, and what else?
20 and 60.
20 and 60. Okay, looking at this, what is going to be your y2?
80.
80 is the larger of the y values. That means this has to be x2. Miss Vega, what does this have to be then? y1, and this has to be x1. Good. We're going to now substitute that into our formula to find the slope. Lava, what am I going to write when I substitute this into my formula?
You're going to write 80 minus 60 over 15 minus 20.
Okay. And when I do the math here, I will get 20 over negative 5. And that simplifies down to what? Anybody?
Oh, 20,
Negative 4.
What happened?
-4.
Negative 4. 20 divided by 5 is 4, but we have a positive and negative, so my slope is negative 4. Because it simplifies down to a whole number, we do not leave it as a fraction. We make it a whole number. In this case, my whole number is negative. Sebastian, back to you now. We want to find the initial value. Are you with me? Okay. So, we know our slope. What xy coordinate pair do you want to use to plug into my equation?
10 and 100.
10 and 100. So we have y equals mx plus b. My m equals -4, and my xy coordinate is 10, 100. Let's play the substitution game. Alrighty, Sebastian, come on down and tell us, what are we plugging in for y? 100, this is my y value, so I'll plug it in for 100. And 100 equals, what is my m? What's my slope?
-4.
-4 goes right here, parentheses. What is going in the parentheses? 10, beautiful, plus b. Now you do your multiplication, you'll end up with 100 is equal to, anybody?
-40.
-40 plus b. Good. Sebastian, finish it up. What do I do to solve this here equation?
-40 minus 4.
No, this is a -40. What's the inverse or the opposite of a -40? Good. We add 40 to both sides. On this side, they will cancel out. And what is my y-intercept going to be, class?
140.
140. Do I have enough information to write an equation now, Brianna? Yes or no? Can I write an equation now? Okay, so Brianna, for the big prize of one measly ticket, can you tell us what would that equation be?
Y equals -4x plus 140.
Beautiful. Y equals -4x plus 140. Good job. Tell her what she's won, Matt. She's won a ticket and an unexpected trip right to her desk. What happened?
That's -40.
What do you mean -40?
There's -4 times
Didn't we solve this? We got -4 times 10. That gave us -40.
Yeah.
We had 100 equals -40 plus b. Let me make it bigger for you here. We had 100 equals -40 plus b. Did we solve for b at this point?
No.
No. So what we had to do here, we had to add 40 to both sides. What happened to these two 40s right here?
They cancel out.
Cancel out. So my y-intercept was not -40. My y-intercept was in fact.
No, I'm talking about the x, where it says y equals, what you said, y equals -4x.
Yeah, but
Is it -40x?
it's not -40x. What was my slope? We found it over here.
-4.
-4. What you're talking about is we plugged in the xy values in order to find b. Once we find b, we don't need those xy coordinates anymore. We write the equation out as y equals my slope, which is, what's my slope? -4. Y equals -4x plus my b, which was 140. You got it?
Yeah.
All right, good. Emily, what you got?
Can be negative.
My b could be negative, my slope could be negative, my b and my m could be fractional, they could end up being decimals, they could be whatever, positive, negative, decimals, whatever you want. They could be whatever. They must be a numerical value of some sort.
Why did you
What did I add?
Yeah.
Where? Right here?
Because 140 is 100 plus 40.
Right here. Here's why. Here's why I added. Let's just do it again. We had 100 is equal to -40 plus b, right? At this point. Now, my goal is to get this alone by itself, right? So this is a -40. In order to get this alone by itself, I have to do the inverse, the opposite of whatever this is. This is a -40. What's the opposite of a -40? Positive 40. So I add 40 to both sides of the equation. On the right side of the equation, these will cancel out. You with me? And 100 plus 40 gives me 140. I bring down my equal sign, and that gives me b. See what happens? We're in the middle of filming this video, and it's just, phone just gonna go off a random. It's okay. I'll survive. Now you're just in here in that class with this phone that went off. Any questions on this at all? Questions? Questions? This, yes.